Hello students, in today's video we are looking at the concept of direct variation, which is a special type of linear relationship. Direct variation is defined as an equation of the form y equals kx, where k is the constant of variation. So if k equals 2, your equation is going to be y equals 2x. So since the equation is y equals kx, y equals 2x would be what that equation looks like. If we take several examples here for a table, we can evaluate that equation at -2, -1, 0, 1, and 2. This is just a sample size. All we did was take these values, substitute them in for x, and here's our table that we got back, plotted those points, and connected them. If you will notice, the origin is included in this line. All direct variation goes through the origin. Not all lines, just all direct variation. And we have several examples on the next sheet. So the first example is a word problem where you are buying several markers for 70 cents each. That is your constant of variation. Things vary by 70 cents. So we are going to write an equation to describe the cost of buying markers. So that's going to be 70 cents is the same as $0.7, so it's varying by 0.7, so that's why k is 0.7. So all we do is substitute k into the y equals kx formula, and there you have your equation for direct variation of this word problem. For the next word problem, they give us a point. The point is 5, -20. This point is on the graph of a direct variation line, so they want us to write the equation. Well, they give us x and y, but they don't give us k, so we need to know what the constant of variation is. So we use the x and y that they give us and the equation form for direct variation. We substitute in the values of x and y, and then we solve for k. So we find that our constant of variation is -4. To get the equation, the general equation that'll find all the points for that line, we just substitute k into the y equals kx form, and there's our equation for direct variation. We also will be using proportions because basically direct variation is a proportion. So here we have a building that is 380 feet tall and 90 feet wide. The scale model of the building is 12 inches tall, and they want to know what the width of the scale drawing is. So we're going to set up a proportion, tall to wide. So that gives us 380 tall to 95 wide is going to be the same as 12 tall to some unknown value wide. So for solving proportions, remember that we cross multiply, which means that we are crossing over the equal sign. We're going to multiply both sides by, or multiply x on and the 380, and that product is going to go on the left side. Take the 95, move it over with the 12, and 95 times 12 is 1,140. Divide both sides by 380 to solve for x, and you get 3. So the width of the scale drawing is 3 inches. Another example, if the words varies directly are in the word problem, then you can set up a proportion. Height varies directly as ascent time, or how fast they're going up, how fast they're moving, and that's going to be in minutes. So we have height in feet, time in minutes. So we know that it's 50 feet for every 2 minutes. So how many minutes when it goes 3,500 feet? Again, cross multiply, we get 50x equals 7,000. Multiply both sides by 50, and x equals 140. So it would take 140 minutes to ascend 3,500 feet. Apologize for the noise there. So here are the notes for direct variation. It is a line that has this type of equation, y equals kx. There's never any adding or subtracting. It's simply multiplying some number, some constant number by x. They were always going to be a line, and it is always going to go through the origin. You can set them up as a proportion, which is typically a little bit easier to solve. If they give you a point and you have to find K, then you use the values in the point, use the equation, solve for K, and then just write down the general equation. Please remember with money that 70 cents is the same thing as 0.7, and be careful with your money and your decimals. And there is direct variation.